Hello everyone, this is COM 300 Exam 3 review video. And in this video, I will first talk about Exam 3 information and I will review main contents on the covered in the Exam 3. So first, for the Exam 3 information, Exam 3 will be on this Thursday, December 7th at 1 p.m. to 2:20 p.m. and also the lecture room. And there will be 40 multiple choice questions. Students should prepare a pencil, student ID card, and calculator. And also the phone calculator is not allowed. And you can check the Exam 3 study guide with some practice questions, mainly about calculations on B12. And then I will review the Exam 3. So the review contents are like this. So first, I will talk about sampling distribution and standard error. Then we'll go to confidence intervals, hypothesis testing, and I will talk about two types of errors. And then we'll review some statistical analysis like chi-square test, t-test, correlation, and finally, we'll briefly cover research ethics. First, I will talk about the sampling distribution. So as we discussed in the recitation and the lecture, there are population at the sample, and the characteristics of the population is parameter, and the characteristics of the sample is the statistics. So the population is a whole group of people, and we draw a sample, which is a portion of the population, and by analyzing the characteristics of the sample, we try to investigate or estimate, predict the characteristics of the population. So the probability theory provides a basis for how we can estimate the parameters of the population. So by looking at the sample or based on the characteristics of the sample, which is statistics, researchers try to infer or generalize from a sample to a population to predict or estimate the characteristic of the population or parameter. And this kind of generalization from a sample to population is called statistical inferences or inference statistics. And according to a probability theory, by just looking at a single sample selected from a population, we can estimate the population parameter. Then how can we do that? How can we estimate the characteristics of population based only on a single sample? And by analyzing the sampling distribution, we can estimate the characteristics of a population based on a single sample. Then what is the sampling distribution? The sampling distribution is defined as the theoretical or hypothetical distribution of statistics like sample means, which is calculated from all possible samples of a certain size. So basically, theoretically, from a population, we draw many samples, and for each samples, we get the sample statistics like sample mean, and from each sample, we can get a sample means. Theoretically, by drawing a lot of samples from the population, we can get lots of sample means, and then we can draw some distribution of the several sample means, and this is makes the sampling distribution. So this is how the sampling distribution works. So sampling distribution is the theoretical or hypothetical distribution of statistics or the distribution of the sample means. Then how we can create some kinds of sampling distribution? So let's imagine that we have 10 cards, and each card has a number from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 cards there. And then first we can select the 2 cards and calculate the mean. So if I draw 2 cards, 1 and 3, and the mean of the 1 and 3 is 2. So in this way, we can draw samples several times. So first we draw the card 1 and 3, record the mean, which is 2. We can repeat it several times and put the cards back, draw another 2 cards and record the mean and put the cards back. So in this way, theoretically, we can draw several samples several times, and from each sample, we can calculate the mean of the sample, which is the sample mean. So we can repeat it several times. Select 2 cards, calculate the mean of the 2 cards, which is the sample mean, record it, and put the cards back. And next time, draw the card like 1 and 5, record the mean. The mean is maybe 3, and then put the cards back and draw the cards 2 cards like 4 and 6, and the mean is 5. So in this way, we draw the sample, record the mean of the sample, then put those samples back and draw another sample and record the sample mean. We can repeat it several times. This is how, in this way, we can draw a lot of samples and get a lot of sample means. So every time you draw 2 cards, every time I draw a sample from a population, the mean of the cards or the sample mean might fluctuate slightly. So for example, I draw card 1 and 3, 2. Next time I draw card 6 and 8, the mean is 7. And I draw the card 3 and 5, mean is 4. And I'll just compile all these means into a single distribution. So the x-axis shows the mean of the sample or mean of the cards, and how many times we get those means, the frequency of means. And when we do this process repeatedly, then we can get a lot of means or a mean of the cards, which is we can get several means or several sample means. And these means we get from each sample will be normally distributed. Like mean of the sample mean of 2, this is just occur 2 times. The mean of 4, sample mean that is appeared like 4 or 5 times. Mean of 6, this has maybe appeared like 7 or 8 times. So that through this process, we can see this kinds of normal distribution or distribution of mean of samples, distribution of sample mean drawing from the each sample. And this distribution is called sampling distribution. So to summarize, there's a population. We draw a sample several times, and from each sample, we calculate the mean. These are sample mean, and because we draw several samples from the population, we can get lots of sample means, and those sample means will be normally distributed, and this distribution of the sample means is sampling distribution. So in the real kinds of like situation, we don't need to draw a lot of samples. We can only look at a single sample, but hypothetically, we can draw a lot of samples and can create a sampling distribution. Okay, so this is basically about how the sampling distribution is created. So you can remember what is the definition of the sampling distribution. The sampling distribution is hypothetical distribution of the sample means. Then what is the characteristics of the sampling distribution? So first characteristics is that under certain conditions, the sample means or sampling distribution is approximately bell curved like this here, and the mean of the curve is likely or similar to the mean of the population. So this is the sample mean, the mean of sampling distribution. The mean of sampling distribution is probably similar to the mean of the population or true mean. And also we can calculate the distributions of the sample means, which is called the standard error. So calculate how the sample means are widely dispersed or sample means in the sampling distribution are clustered around certain values, and these kinds of standard deviation of the curve or standard deviation of the sampling distribution is the standard error. So I will go next to the standard error part. Standard error is defined as a standard deviation of the sampling distribution, the distribution sampling distribution, or the standard deviation of the sample means in the sampling distribution. So the standard error indicates the extent to which the sample estimate will be distributed around the population parameter. So maybe the population mean might be located this, and there are a lot of sample means in the sampling distribution, whether this sample means are widely distributed or not. This shows the standard error. So, or how the sample statistics or means in the sample distribution is distributed. And then in the exam, you will also calculate standard error. The standard error calculation is not that complicated. So the formula is like this. The standard error is equals to S divided by square root of n, which means that standard error is equals to standard deviation divided by the square root of the sample size. This is how we can calculate the standard error. Then we can go next to the confidence intervals. So basically, we can, in the statistics, we only look at the sample, and by analyzing the characteristics of the sample, we can predict the characteristics of the population. However, the sample is just a portion of the population. So through the sample, we can only have a partial information about the population, which means that we can predict the characteristics of the population based on the sample, but not in a 100% exact way. 100 is not 100% accurate. However, by looking at the samples and analyzing the characteristics of the sample, we can narrow down our range of population means to the specific interval, which means that we can look at the sampling distribution and we can see the sample mean. And by calculating some confidence intervals, we can know the range of the true mean or range of the population mean. So for example, if we know that, okay, the mean of the sample is 50, then we can say that by calculating confidence intervals, we can say that the population mean or true mean might be between 48 or to 52, closer to 50. This is what the confidence interval is doing. So the confidence interval, through confidence intervals, we can express the accuracy of our sample statistics in terms of levels of confidence. And confidence interval is a range of values within which the population value is estimated to be located. And also we can calculate the confidence intervals in the following way. So the formula, so in the exam, we need to calculate the confidence intervals as well, and maybe is 95 confidence intervals. So 95 confidence intervals is calculated the following way. So, okay, I just have to say 95 confidence intervals. Here, okay, remove it again. So 95 confidence interval equals to x plus minus 2 times standard error. We already calculated the standard error. Standard error is standard deviation divided by the square root of the sample size. And x is the mean of the sample mean. So mean of the sample plus minus 2 times standard error. That's the 95% confidence interval. So basically, the confidence interval is about the range. So let's think about this example. The example is like this. The sample of 64 students' quiz scores here, and students' mean score, or the sample mean is 30, and standard deviation is 12. So what is the n? how many people here in the sample? 64. So the n is 64, and standard deviation is given, it's 12. Then, based on this, we can calculate the standard error. Standard error equals to standard deviation divided by square root of n, which equals to 12 divided by square root of 64, 12 divided by 8, then the standard error is 1.5. Good. Then based on this information, we can calculate 95 confidence interval. So 95 confidence interval is equals to x plus minus 2 times standard error. So the sample mean of x is already given. This 30. The standard error we calculated is 1.5. Just put the numbers in the formula. Then 95 confidence interval equals to 30 plus minus 2 times 1.5. So the confidence interval is about range. So this is about 30 minus 3, from 30 minus 3 to 30 plus 3. So the 95 confidence interval is 23, from 23 to 27 to 33. Then what is the meaning of the standard error of 1.5 and 95 confidence intervals, like 27 to 33? So which means that the standard deviation of the sampling distribution or standard deviation of the sample means is 1.5. And also, what is the meaning of the 95 confidence interval? Which means that the population mean might fall between 27 to 33 with 95 confidence. Let's think about these graphs here. We already have the mean of the sample, but we try to estimate what is the mean of the whole population, or what is the true mean. But based only on the sample, we cannot have the 100% exactly accurate information. So by calculating the confidence interval, we can estimate that maybe the sample mean is 30, but with 95 confidence, the mean of the population or true mean might be located between 27 and 33 with 95 confidence. In a more accurate way, 95 out of 100 confidence interval would overlap with the population mean. But that's what is the meaning, why the confidence interval and the mean of the confidence intervals. So population mean might fall between this range of confidence intervals. So we reviewed sampling distribution, standard error, and confidence interval. And in the exam, you have to understand this concept. What is the standard error? What is the sampling distribution? What is the confidence interval means? And then also in the exam, you have to calculate standard error, confidence interval, and also interpret the result. In the next part, I will go over the hypothesis testing and we'll review some kinds of statistical analysis we did in the recitation. So first, in hypothesis testing, before we do some statistical analysis, we can think about two different scenarios. So first scenario is the null hypothesis. Another scenario is the alternative hypothesis. So null hypothesis about prediction that there's no relationship or no differences between relevant groups. For example, like there are OSU students and MSU students, if we predict that, these are kinds of prediction that there's no differences in happiness between MSU and OSU students. That's the null hypothesis. However, if I predict that there's some relationship or differences between groups, like OSU students might be more happier than the MSU students, or OSU students' happiness is different from or MSU students, that's the alternative hypothesis. So in the hypothesis testing, we can think about two different scenarios. Null hypothesis no relationship, no differences between group. Alternative hypothesis, there's some significant relationship or differences between groups. And by doing some statistical analysis, if there is a significant, or if we find some significant relationship or differences between groups, then we can reject the null hypothesis, which means that we accept the alternative hypothesis and there is a significant relationship between groups or variables. However, after doing some statistical analysis, if we found that there's no significant relationship or differences exist between groups, then we cannot reject the null hypothesis. But this is about how can we do some hypothetical testing. And when we do some hypothetical testing, sometimes researchers made mistakes, some error. So we can think about these two different types of errors in the hypothesis testing. The first one is type 1 error, and the second one is the type 2 error. In the type 1 error is about we reject the null, but it is true, which means that in reality, there's no relationship or no differences between groups. However, researchers made a mistake and found the inaccurate conclusions like there's a relationship between or there's a differences between two groups. That's the type 1 error. Let's think about this example. In reality, true, actually, there's no relationship between social media use and depression. So there's no relationship between social media use makes people depressed. However, one researcher made a mistake in asking questions in the survey and made some inaccurate, wrong this conclusion and say that there's a relationship between social media use and depression. But this is false. This is not true. And they made a type 1 error. In reality, there's no relationship, but they made a mistake and made a wrong conclusion saying that there is a relationship. So in type 1 error, we should not have rejected the null hypothesis, but the researchers reject the null hypothesis. However, in the type 2 error, that's a totally different situation. The null is not rejected, but the null is false. That in reality, there is a relationship, but researchers made a mistake and made a wrong conclusion saying that there's no relationship between two groups. So for example, in a different situation, a type 2 error, in reality, there is a relationship between social media use and depression. However, researchers made a mistake and made a wrong conclusion saying that there is no relationship between social media use and depression. And that's the type 2 error. So to summarize, type 1 error, we should not have rejected the null hypothesis, but they rejected the null. The type 2 error, we should have rejected the null hypothesis, but the null was not rejected because of the error. That's the type 1 error and the type 2 error. Then we can go next. We'll review some statistical analysis we practiced in the lecture and the recitation. First, I will review chi-square test. I will not do some statistical analysis or calculation because we practiced it several times in the recitation. And then I will go to the t-test and I will review the correlation. First, we already practiced the chi-square test in the recitation. And basically, the chi-square test is about to test the hypothesis to examine whether observed frequency or observed count, that's the same words, observed frequency are different from expected frequency in categories of the contingency table. So maybe you can remember there's a kind of table here, and we calculate, we observed frequency is given, and you calculate the expected frequency and summed it. There's a chi-square statistics, and compare with critical value and made a decision. Yeah. So for review, the steps of chi-square test is like this. First, you can state null hypothesis and alternative hypothesis. And then you can calculate the expected count or expected frequency. That's the same thing for each cells. So observed frequency or observed counts is given, but you have to calculate the expected frequency or expected counts. Then you will calculate the chi-square statistics, and you will compare the chi-square statistics with critical value. In the 2x2 contingency table, the critical value is always 3.84. That's the given in the 2x2 contingency table in the chi-square test. So you calculate the chi-square statistics and compare the critical value 3.84. And if the chi-square statistics is higher than the critical value, you can reject the null hypothesis. However, if the chi-square statistics is lower than the critical value, you will not reject the null hypothesis. So for the review, the formula is like this. So for the chi-square statistics, this icon, this signal shows that you have to sum the values. So chi-square statistics equals to sigma. For each cell, you will have observed frequency minus expected frequency squared divided by expected frequency. And for each cell, you will repeat this calculation and sum it, and that's the chi-square statistics. So we already practiced the example in the recitation. So the blue one is the observed frequency or observed counts. That's the given. And the yellow one is the expected frequency that we have to calculate. So for example, this example shows that whether MSU and OSU students' likelihood of having driving license are equal or not. So this cell shows the MSU students with driving license, MSU students without driving license, OSU students with driving license, and OSU students without driving license. So blue one is the observed frequency, and the yellow one is the expected frequency or expected counts. You have to calculate it. How can you calculate it? For example, the MSU students with driving license, this cell, the expected frequency is MSU student the number of MSU students, and number of driving license, and the total number of people. So 110 times 140 divided by 240. That's the expected counts for MSU students with driving license. How about this cell? OSU students without driving license. The 40 is the observed frequency, that's the given. But for the expected frequency, we have to calculate it. So for this cell, the number of OSU students, 130 times 100 for people without driving license divided by the whole people, 240. And we can calculate the expected frequency. And then for each cells following the formula, we'll calculate this one. So for cell 1, MSU students with driving license, observed frequency minus expected frequency squared divided by expected frequency, blah, blah, blah. We calculate it and get this value. You can repeat it for each cell. And if you sum it, that's the chi-square statistics. And you will compare the chi-square statistics with critical value 3.84, and you will make the decision whether reject the null hypothesis or do not reject the null hypothesis. That's all about the chi-square statistics, chi-square test. Then we'll go to the t-test here. The t-test is to test the hypothesis about comparing means for groups in the population. So in the recitation, we talk about whether MSU students are more happier than the OSU students, we compare the mean of happiness between OSU students and MSU students. So steps of doing t-test is like this. First, you will calculate the t-statistic following the formula, and then you will calculate the degree of freedom, and then look up the critical value in the t-table. So in the t-test, critical value is not given. You have to look up the table and find the value. And then compare the t-statistic with a critical value. And if the t-statistic is higher than the critical value, you can reject the null hypothesis. However, if the t-statistic is lower than the critical value, you cannot reject the null hypothesis. Then how about the formula in the t-test? So in the t-test, you have to calculate the t-statistic, and the formula is like this. T equals to x1 minus x2 divided by xx1 minus sx2. X1 is the mean of group 1, like mean of happiness in OSU students. Minus 2 is mean of group 2, and divided by this part, the standard error of the differences of the mean. So you don't need to calculate an exam, that will be given. So you will get the mean of group 1 minus mean of group 2 divided by the standard error of the differences of the mean, and then you can get a t-statistic. And also, please note that the mean of group 1 should be higher than the mean of group 2. So the t value is the positive values. It's not statistically true, but that is beyond this course. So when you calculate t-statistics, you can just put the high numbers in x1 and lower numbers in x2. And also, you have to get the degree of freedom in the t-statistics. The formula is degree of freedom is n1 plus n2 minus 2. N1 is the number of observations in group 1, like how many people in MSU. N2 is the number of observations in group 2. And then minus 2. And based on the degree of freedom you calculated, you will go to the t-table and look up the critical value. So, for example, if the alpha level is 0.05, and if you do the two-tail test most of the time, and if you calculate it and the degree of freedom is 28, you will go to t-table. So a t-table like this. Here is the two-tail test. Okay, two-tail test, but alpha level is 0.05 here. And there are a lot of numbers here. And then this is DF, is the degree of freedom, 1, 2, 3, blah, 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 blah. And if you calculate it, you get the degree of freedom is 28. This is the number here, and you can match the number. Two-tail test, alpha level 0.05, and degree of freedom 28. And the value is 2.048. Then you find the critical value, which is 2.048. Then you will compare the t-statistics with critical value, and which one is higher. And then you can make the decision whether you will reject the null hypothesis or not. If you reject the null hypothesis, which means that there is a significant differences between groups and between relevant groups. And also in the t-test, you can think about what is the one-tail test or what is the two-tail test. So one-tail test is about when the hypothesis states that one group is higher or lower than the another. So for example, if you say that if you hypothesize that MSU students are more happier than the OSU students, or OSU students are less happier than the MSU students, then that's the one-tail test. So in the one-tail test, there is specified directions, whether a group A is higher than the group B, or group B is lower than the group A. Or if you say that A increases B or A decreases B, there's a specific directions. Then that's the one-tailed test. However, in the two-tailed test, there's no direction. So it just say that state that one group is different from the another. MSU student happiness is different from OSU students. So A is different from B. Maybe they can increase or decreases. One group is higher or lower, but we are not sure. We didn't hypothesize that. We only hypothesize whether A and B is different or not. So there's no specific direction. And in this situation, we can do two-tailed test. So you can think about different scenarios of one-tailed test and two-tailed test, whether there is a direction or not specific directions. And also we practice the correlation test. So also we practice whether the correlation is significant or not. So all the steps are really similar to the t-test, but the only difference is the formula of t-statistics and degree of freedom. So for the correlation test, the steps are like this. We can calculate the t-statistic first, a different formula. Please note that. Also, we can calculate the degree of freedom, also different formula. And look up the critical value in the t-table, that's the same. And we can compare the t-statistic with the critical value. If the t-statistic is higher than the critical value, we can reject the null hypothesis. Then, which means that there is a significant correlation. However, if the t-statistic is lower than the critical value, we cannot reject the null hypothesis. It means that there's no significant correlations. And the formula in the correlation is like this. So this is also called the t-statistics, but the formula is different from t-statistics in the t-test. This is the formula for correlation. The formula is like this. The t equals to r times square root n minus 2 divided by square root 1 minus r squared. So R is the correlation. That's the key. And N is the number of observations. How many people there? So you can just put the numbers in the formula and then calculate it, and you can get a t-statistic for correlation test. And also, you can get the degree of freedom, which is n minus 2. So N is how many people there, number of observations. The degree of freedom is also for correlation. So by calculating t-statistics and degree of freedom, you can go to the t-statistics t-table and two-tailed test. If that's the two-tailed test, alpha level 0.05, degree of freedom, find the critical value, and compare the t-statistics with the critical value and make the decision, reject the null hypothesis or not. So this is what the correlation analysis is doing. So in this way, we practice 3 types of statistical analysis, like chi-square test, t-test, and correlation test. In the last section, I will just review some research ethics, but I will just talk about it briefly because you already learned it in the lecture last week. So in the research ethics, you can review some kinds of terminologies and example of studies, like replication. What is a replication? What is the consent or deception? So just for the briefer review, replication is that the published studies reproduce the same result in the other studies. For example, if one study shows that social media use makes people depressed and the other study also shows the same result, and that's a successful replication. And also you can think about the other terms like respect for persons, which is about every person has the right to determine what shall happen to the participants. And beneficence is about no person shall be placed at risk, and justice, risk and benefit should be justly distributed consent, what is the deception, is deceiving people just for the purpose of the study, and what is the open science, is pre-registration, so make some like more transparent about the procedure of the study. So in this way, in the research access parts, you can remind and review some terminologies. So this is all about the exam 3 review video. So good luck with the exam. And I want to say again, don't forget to bring pencils, student ID, and calculator. And phone calculator is not allowed. So please bring some kinds of old or traditional calculator so that you can calculate some t-statistics or chi-square statistics. And also, thank you for taking this class. They're one of the very like difficult courses in the department. But thank you for taking this class and thank you for your efforts. And hope everyone good luck with the exam and have a great like winter breaks. Okay, see you. Bye bye.